In this video, we are practicing solving trigonometric equations. We have a fairly straightforward trigonometric equation, and this problem says, find the solution set, that means find all the values that make the equation true, of the equation 7 times the tangent of theta is equal to 2 radical 3 plus the tangent of theta in the interval 0 is less than or equal to theta is less than 360. So that we have room to work, I'm going to bring the equation down. So this is 7 times the tangent of theta is equal to 2 radical 3 plus the tangent of theta. Excellent. So let's try to isolate the function part of this equation. That's really the way you solve any equation. First you try to isolate the function, and then you undo the function with its inverse. So, I notice that the tangent of theta shows up on the left side and on the right side. We really need to have just one tangent on one side in the end, and so what I will do is I will subtract a tangent of theta from both sides. So here we're subtracting the tangent of theta, subtracting a tangent of theta. 7 tangent of theta minus the tangent of theta gives us 6 tangent of theta, and this is equal to 2 radical 3. Now to isolate this tangent of theta, we divide both sides by 6, and we end up with the tangent of theta is equal to 2 radical 3 over 6. This can be simplified a bit. 2 over 6 is the same thing as 1 over 3. And so this means that the tangent of theta is equal to radical 3 over 3, right? Because this is a 1 over 3. Excellent. Now, this looks very familiar to me. If you remember from the table of trig values of special angles, which is something that you need to have memorized, you should remember that theta equals 30 degrees is one of the angles that makes this happen. The exact value of the tangent of 30 degrees is radical 3 over 3. We know that because it's a special angle. Excellent. Now, of course, this isn't the only angle that does that trick. We can find the other ones by drawing a unit circle. Here's my x-axis, there's my y-axis. And estimate where 30 degrees is. 30 degrees is about here. This is an angle of 30 degrees. And because this is a tangent, what should we reflect it through? You're absolutely correct if you said that we should reflect this 30 degrees through the origin. For a tangent, you reflect through the origin, and so it takes us over to here. Well, what is the size of this larger angle then? This larger angle is the 180 degrees it takes to go from there to there, plus 30 more, since if this is 30, then the reflection means that this is 30. So it is 180 plus 30 more, which is 210, right? This is 180 plus 30, so we end up here at 210. These are the only solutions we need because this was specifically saying that it wants the values of theta that are between 0 and 360. So here are the values of theta between 0 and 360, which give us solutions to this equation.